go ahead and get started. I would like to introduce my good colleague and friend, Dr. Deepak Khazanchi. He's the professor of Information Systems and Quantitative Analysis, Associate Dean for Academic Affairs and Community Engagement and Internationalization Officer in the University of Nebraska at Omaha UNO College of Information Science and Technology. That was a lot of words. He has been very instrumental in helping people develop different information systems technology for research, education, and consultant. And he's going to talk today about his group, how they use undergraduate and graduate students and staff collaboratives to build software solutions and platforms, mobile, web-based, for medical research interventions and learning. So without any more introduction, I gladly introduce Dr. Deepak Khazanchi. Deepak.
Thank you, Gigi. Appreciate being invited. And what I'm going to do is basically take a bit of the time to talk about what we have done so far. I mean, and I'm going to talk about more recent projects than, I've been doing this for about 20 years, so in Omaha alone. But also just kind of give you some context of how we kind of work in the college and taking in projects, and then building platforms that are useful for both research and education, as Chichi said. So let me just share my screen, and I'll take it from there. All right. So what I want to do is just kind of briefly touch on some context that drives what is happening in academic medical research or informatics research in many ways. E-health technologies are not limited just to the people who are technology savvy now, as all of you probably are well aware. And COVID-19, in fact, has in some ways accelerated the adoption of technologies, particularly in behavioral and social science research. Now, my background is in information systems research, which is a combination of behavioral social science and information technology. In the medical research and medical education and medical practice domains, it's just been in the recent few years that things have really picked up pace, and during COVID, it's even more so than before, like, having contact tracing apps that are used for COVID in some of our states in the US. In some countries, those are required. The reason for this is kind of important to understand. There are more than 3.8 billion people who own a smartphone at this, the last I looked at this data. And the prediction is that this is expected to further grow by several 100 million in the next few years. And if you think of the three largest countries that have the highest number of smartphone users, and if your research is going to go beyond the North American borders, I mean, China, India, and US are leading the charge on adoption of these mobile platforms. And then the other interesting stats that I looked at this many years ago, and I just looked at it before this presentation, and it's interesting. Now, more than 79% of minority and low-income populations have smartphones, according to Pew Research. And nearly 83% of this population uses smartphone as their primary means of online access at home. So even if you don't have wired internet access, you may actually be using it for using the smartphone. So this is the context in which we are operating. And then the other part that is kind of growing and continues to grow are the wearable devices. Whether you're talking about pedometers or heart monitors or insulin monitors or smartwatches, whatever you think of in terms of wearables, these are growing both in availability, price, and adoption. at this, the last statistics from Statista was that 24% of US adults already use some type of wearables, and this is expected to explode as these become more commoditized. So, given that context, what I want to do is kind of share with you a few of the projects that we have done, and then talk to you about what are the things that are amenable to our college and my specific group in terms of the kinds of interventions and technologies we are familiar with. So the most, and Chi-Chi said this, that this is a recent app, the last year or so that we built. It's an iPad app, and it was built for Dr. Ghate and a team in the Trulson Institute. And this has been now published in the British Journal of Ophthalmology, and in fact has very interesting reactions from even the general media. So basically, the idea here was that we were given the concept that the problem that, hey, we want to study glaucoma patients in the lab, but generally the clinical practice is that we ask the patients, through clinical interaction in during their visits about things that are not visible to them, and these are anecdotal rather than objective. So Dr. Ghate and her team wanted to try to make this as objective as possible. And so what they thought of was that, we could show a poster of a realistic ground truth to subjects, and then give them an app on an iPad, which is close to them, where they can actually try to compare what they see on the poster with the same image on the iPad, and then use some editing tools that we provided to hide portions of the image that they don't see, or blur portions of the image that they don't see. So you will see that these A, B, C, D, E images are essentially showing the way the user interacts with this image, with this poster, and then with the iPad. So what we did was we built an iPad app that essentially you can load an image that you're showing to the subjects, and then the app will essentially, once you provides all these editing features where you can blur and dim areas of the image that are not visible to you or partially visible to you as a subject. So now the subject themselves is interacting with the app rather than verbally explaining what is happening to them, to the clinician. So, and then we could store the images as they were finalized by the subject, and we would be able to also do the HIPAA compliance and all that by storing them on UNMC servers. So we work very closely with the UNMC staff to kind of do that. So this is an example of a recent thing that the study was completed, published, and it's actually in its next phases of hopefully asking for more funding. So to scale up the study. So this is an example of a recent iPad-based app that was used. We are working with Chi-Chi and her team on mobile health intervention, and where we are trying to build a platform, and this is currently under progress. But I thought it is interesting to present because we're talking about e-health in general. And we are building a platform on which we can do goal-based research relating to mobile health interventions. And we have many interesting features that we are building into this so that the platform is scalable to any kinds of research studies. So there is a customization portion, there is a patient self-monitoring portion, there is a data collection portion, and then obviously from the researcher's perspective, there is a research monitoring element. And we are building it very analogous to almost like a Lego structure. So you have building blocks that you can combine to do a study as a researcher, and these building blocks can be customized to each researcher's investigation. So our goal is to make this as flexible as we can given the technology constraints. So this is an example of something that we are doing, again, in terms of research interventions. Now, on the other side, we are also doing some educational things. So with COVID being so prevalent, Dr. Khan from the Dean of Public Health came to us and said, hey, I want to build a game for kids to understand pandemics. And so we built a game called Zoodemic, which is actually currently available for download. If you have kids or nephews or nieces who want to learn about this, it's available from both the iOS and Android platform. But basically, we build this as an educational serious game. So essentially, we used a lot of information from public health sources like CDC and the University of Iowa and the University of Nebraska Medical Center to create almost like a virus game. And it has many levels, including ultimately a COVID level, which is our next phase of development in this. But again, we also do game construction, depending on whether it's educational, research. In the past, we have for Dr. Davis's, Deli Davis's effort on creating e-modules for pedagogical use, we have done a bunch of visualizations in games that are useful for that. So again, we have the expertise to do this for different domains. The other interesting project that we're doing right now, I thought I would share, is we are doing some mobile apps for capturing mobility for Dr. Joseph Su and his team.
Can you put it inside your case?
For his team. So here we are using machine learning and computer vision technology to essentially capture a person walking, running, and then picking the coordinates of different parts of the body from that without actually putting a colored marker on that. So this is one of the options we are evaluating right now. And we have been successful in finding the coordinates of different parts of the body. Now the question is, how is that used in real-time mobile capture? And can you do it effectively and efficaciously? So this is an example of where we are using standard machine learning services and computer vision algorithms to actually pull coordinate data of the physical movement. And this has applications in physical therapy, but also in biomechanics and also in sports medicine. So I think we are currently at a very early stage in this development. In the past, we have also done work in three-dimensional environments like Second Life, where we have created realistic experiences for people. For example, this was a high fidelity three-dimensional experience to evaluate community health challenges in a small virtual town. So, this was built for one of the faculty on the chair, Cheryl Thompson, actually, who did a study on this a few years ago. We have also done things like visualizations where we create short animations to educate people about the pathophysiology of the headache. And this is kind of an animation that was built for Dr. Larson. Similarly, we have done some games like a rheumatology game where you can actually play the game and learn concepts relating to the pharmacological aspects of different clinical scenarios in rheumatology. Again, this is actually still available to view online. The last one I'm going to talk about, again, it's a game. It's a gout racer. It's basically, again, another game that was built in an old pixelated format for teaching people about the impact of different kinds of dietary aspects, treatment, etc. on gout, and you learn that in the context of a game. So these were built for faculty in UNMC. We also do a lot of work with community organizations, so which I am not sharing today, but we build, my group builds apps and web applications for nonprofits in the city. We have done that for many organizations in the city. So that kind of gives you a sampling. We have expertise in visualization, in app development, in both pedagogy and research-oriented technology development. And also we understand how data needs to be stored from a HIPAA perspective and all that stuff. So we kind of understand the ecosystem of how to manage all that. So there are certain things that we have learned, and I thought one of the things about a good talk is to give you some best practices. So I can tell you a little bit about what we have learned and what these lessons mean from a researcher perspective, from an educator perspective in the medical science domain. So if you are considering technology interventions, or you're considering technology as a tool to deliver pedagogy, we have learned a lot doing this for the last 2 decades. So we can at least give you some idea of what to consider when you're thinking about these kind of problems. So I think the first thing that every scientist does is has a research problem and a research question, or an educational goal if it's an educational project. And I think one of the things that we remind everyone is that we are not, we don't think that you can you build a technology solution without addressing what's the foundational basis for what you are trying to propose. So we normally, when we have conversations with researchers, we say, don't worry about the platform or the technology yet. First tell us, what kind of problem are you trying to solve, whether it's pedagogical or research oriented, what are the questions you want to answer, and to answer those questions, what kind of foundational elements exist, what is the basis for your questions. I think that's ultimately the most important thing that we have learned, that you can't just build technology for technology's sake. You got to have something that drives that. And your design of your research has to be substantively clean before you start looking at building technology solutions. Because I think if you start with the presumption that a technology intervention is the best way to go, without looking at whether your design for your research study is clear and consistent with the kind of questions you're trying to answer, the technology intervention really would not work very well. So that clarity needs to be had even prior to kind of considering options of what kind of technology would be useful. So, I think this is something that we talk to PhD students, but I think in general, it's important to understand that the method you propose to conduct a research study, the kinds of interventions you design, the way you want to collect data, the kinds of data you want to collect, how you're going to analyze the data once you have it, will also drive how we would actually collect the data using a technology. So there's a lot of things that need to be kind of done on paper before we jump into a solution. Or even if you're not building a solution, maybe buying something, you want to make sure this is clear before you jump into that phase of your activity. And then I think this is something I have to emphasize again and again, because we should avoid the pitfall of focusing on the technology solution rather than focusing on the research problem. So I think the technology solution, or the technology that is to be delivering the behavioral components, or the other components of your research intervention, needs to be driven by the problem and by the theoretical basis, and the technology should be used to do that as a means to do that. So to be successful in your research. So I have a couple of different things to think about in this. Innovation and technology interventions can only help if we are clear about the problem and the design. So interventions don't work very well if we are not very clear about how we are going to do this upfront. And the other thing is that, the technology interventions can be smart and not so smart. So the effort would vary depending upon how you want to do your study. So I would focus on the science of it. And I would let us focus on the software engineering of it, because we will give you the expertise, not only my group, but we have many other research groups in our college who can provide expertise in different areas to help you do a sophisticated research intervention. And we may sometimes just say, let's buy something off the shelf. I mean, we don't need to build everything because there's so many things out there. But I think the precursor to success with technology intervention is the first two things I've outlined. The other thing is that from our perspective, we generally collaborate with you from the beginning. We prefer collaborating with you from the beginning. So if you're applying for a grant or applying for, doing some research in a specific domain that may potentially have technology as an intervention, we would like to be part of that from the beginning, so that we can help you kind of define the path on which you should go. And also we need to work with the budgets that we have. So sometimes we may not choose technologies because it may be too expensive or maybe too difficult to build in the time frame you have. The other thing I would say is that even if you're going to use an off-the-shelf technology, one of the things we have learned over the years is, it's good to understand the pros and cons. Consulting with us on that to get our feedback, or even having us try it before you do this will help you kind of do a better job in your own research. So, I highly recommend that, get some expert opinion about what you're trying to do as it relates to your research goals. So other things that we can share. The best technology solutions are those that are simple and clear in their purpose. So from what we've learned, what I can tell you is that the kinds of technology solutions that work best are the ones that are very clear in our minds as to what they want to accomplish. Technology-based interventions and experimental treatments, there is no difference between a traditional paper-based research or human intervention in behavior research or any other kind of research. Mixed method research, as I do a lot of my work in, these kind of approaches, it is essential to do a pilot first. So piloting the technology or piloting even a simplistic paper version of what will happen in the technology to clean out any kinks before you actually spend a lot of effort building or buying intervention is extremely important. Then the other thing that I would suggest is that there are some scientific things that one needs to consider if the goal is research, whether it's pedagogical or clinical research. When you make a choice in using technology, right? The question is, one of the questions is the intervention just providing an alternative delivery mechanism? So are you just kind of trying to find an alternative way of delivering your intervention? Is the technology solution additive to the efficacy of your treatment? Meaning additive in the sense that you think that you have a behavioral intervention that works and the technology is going to add to the efficacy of that intervention, or is it just like a way to just deliver the intervention? Those are two different things. From a scientific perspective in our field, and also I would argue from any scientific perspective. The other thing to think about is, would the technology be a potential inhibitor? So for example, if you're doing a research study in rural Nebraska, where there is not enough access to computing infrastructure or to internet access, then we need to either find solutions to get around that, or you may have to think of alternative ways. So would the technology be a potential inhibitor for the intervention, whether it's because of infrastructure issues or whether it's because of the science of the treatment? That would be important to consider. Have you thought about the adoption and diffusion of the innovation that you're trying to do? So if you're thinking of something that has to be scalable, ultimately, then you need to think about, well, will people actually adopt this? Will people actually continue using what I am trying to provide as an intervention, if it is efficacious? And is that even important to your research at this point? So these are some things that I would consider in my thinking. The other thing that I want to share with you is a little bit about artificial intelligence and machine learning, because I think one of the things that I hear a lot about is people want to kind of adopt AI and machine learning, and this is not only on the medical science side, but also I hear that even from companies. The problem is that using novel data analytic techniques is not very straightforward, first of all. And the problem you're trying to tackle needs to be amenable to it. It's not just applicable to anything. So generally, here's my advice. Problems that require prediction, causal inference, explanation with human knowledge and expertise are amenable to artificial intelligence, automation, supervised or unsupervised learning algorithms. So if you're thinking that you want to do something in those areas in your research question, then maybe we can explore machine learning or even other data analytic techniques that are applicable to those domains. So everything doesn't need to be automation oriented either. It could be just some advanced statistical approaches to addressing the problem. One way to think about it is start if you have your research problem and your research design idea in place, then start with distinguishing between problems that can be solved through automation and problems that can be solved through some learning algorithms. So when I mean automation where no learning happens, and the problem is relatively straightforward, and we can basically either statistically or algorithmically address it, even if it is somewhat semi-structured. Automation, some kind of automatic way of analyzing it. So that's possible. When you're thinking of computer vision and machine learning, at their core, these two are also just advanced statistical methods, but they go beyond just solving some straightforward problem. They also have the ability to build on knowledge that is acquired from training data sets, from data sets that have been used in the past. So these algorithms or these kind of software solutions will approach the problem from finding patterns in the data or predicting patterns in a data and learning from those patterns over time. So these methods are really great at determining, what is the features in your data, are they related to certain outcomes you're interested in, can we predict stuff, can we make it self-learning. So these are the kind of things that distinguish the two kinds of categories of solutions in this domain. The other thing that I would say is that one of the fundamental problems in automation and supervised learning based solutions is algorithmic bias. And this is a continuing challenge in our field, because when you use data to train a software algorithm, you are essentially using data that is that's supposedly objective. But a lot of times, a lot of bias is introduced by the data that you use to train your algorithm. So it can also be introduced when you're labeling the data. So there's a lot of challenges that need to be very clearly overcome. And so just applying AI and computer vision and machine learning techniques is not enough. So you need people from our college or our type of faculty who have expertise in that and understand what biases can be introduced to help you kind of move forward with that. Um, the other thing that I would recommend in this domain anyway is that you need to test for efficacy of your AI machine learning approaches and compare it against clinical ground truths in whatever phenomena you're studying. So it can't be just used as a sophisticated technology to solve a problem without actually comparing the efficacy to some clinical ground truth. So just like in the iPad example, where we wanted to compare that result with how a clinician interviews a subject and gets the same information. So that's a very important part of this enterprise. That's kind of a brief overview of project illustrations, and then best practices from our experiences with them. What I want to do next is just kind of briefly talk to you about how we how we actually think about projects. What we do is first, when we at least my research group's goal is to kind of understand what you're trying to do, and we try to figure out what are your goals, what is the research problem you're trying to tackle, how clear are we about the intervention you need, is it for research, is it for pedagogy, and then we try to figure out what kind of technology solution is useful, and we do that in collaboration with you, and then we develop some kind of architecture. And what we try to do is give a scope of work and a budget and a timeline on how long it takes. I mean, for example, when we did Second Life, it was a bleeding edge technology. It was a 3-dimensional platform. We were already doing research in it, so it was easier to adopt it for some clinical work. Sometimes, like we have tried to use the HoloLens for some research on a trial basis. So we can try to use newer technologies, bleeding edge as we call it, to help you innovate in the kind of interventions you're doing. But it all depends on what your goals are. Then in terms of scope, there are, I guess, 3 ways to think about them. One is that you have, you just want to build a prototype system that you want to pilot. The other is more like it'll take a little longer. We want it to a scale where I can deploy it in the field. The other is that you want to scale it in a way that can be even commercially viable ultimately at the end of the day. So those are the kind of projects. And the only thing I can share from our perspective is we use a very agile approach. So that means it requires a lot of investment of time from the people who bring the problem to us, because we are not a company. We are a group of undergraduate and graduate students who work for me under supervision with experts to build software and apply these technologies. We tend to have a lot more interaction with our clients. So that's extremely important to understand, because it requires a time commitment on both sides. It's not, and we don't charge you what a consultant would charge in some ways. So that's part of the reason of this. But we do have checkpoints, and we try to regularly provide feedback and get feedback until we actually deploy the product. We also, if you're going to deploy a HIPAA compliant product, then we will run it through UNMC servers. So that means UNMC and us will together do a cybersecurity assessment. We always do that anyway on our end, but we do a second time when UNMC actually integrates it into their server, if that's a server-based app. So that's something that we do work on very closely with the teams at UNMC. Other thing I can just share quickly is that we do have, some guidance, if you want to think of it. If you're thinking of more of a prototype, the idea here is, hey, I have a concept. I want to use this to teach something. Can you just build me this concept? So this is more like a functional prototype where I'm just trying something out as a pilot. What is possible? Does the design work? Does the idea work? So that's something, translating your theoretical idea to a technological idea. We could probably try to do that more like a prototype system. When you have kind of more of a solid foundation of what you need, where you know what kind of intervention is going to be useful for you or for the research or pedagogical outcomes you want, then it would fall in this kind of intermediate category, which will take us longer, but we will need more descriptive scenarios on how to implement your solution. So a lot of interactive feedback is given to us in that process, and we incrementally build that. And then we're talking about more of a robust kind of platform, like we are doing with the mHealth project, where we are trying to build also management features, where you have it scaled up to the point where every researcher could have their own version of that app, and and they could manage the data themselves. So we try to build solutions that are self-managed by the researcher rather than constantly asking us for help about how to do X or Y. So we really focus on user-centered design, user-focused kind of design of the application. And these kind of products may lead to commercialization, possibly. So that's kind of a summary of what I wanted to share. I have many more examples I can share, but I thought I would share this basic thing. We have a lot of, and I'll share my slide deck later with Heather, but we have a lot of research publications that have come out of our work with people. So I'll leave it here first for any discussion or questions, because I think maybe that will serve your purpose better if I answer specific questions. But if there is no question, I can show you some other examples.
Can I ask a question? How do you know early on whether this is even feasible? I mean, is it something we can explore just initially, or what's a cost?
Well, I mean, I think you have to first, I mean, like I have said, we need to understand what is your research or pedagogical objective, and at least from a theoretical perspective, are you clear about what that means? And then we can do two things. One, we can at least conceptually evaluate, and we don't charge for that, but we can conceptually evaluate whether it's even viable as a technology solution, and even initially propose, like we are doing right now with Marsha, who
Shade.
Shade, yeah. We are trying to investigate whether a voice-based intervention is possible, and do we really need to use a commercial product, or can we build it ourselves? So we do some initial investigation ourselves, but if it requires building kind of a functional prototype, we would probably need like 2 to 3 months to do that and kind of show that this could work, and then scale it to your project. So I don't know if that answers your question, but I mean, it just depends on the complexity of the problem completely. I mean, we may have done it before, so we could probably give you a suggestion right away.
What about collecting biological information, like some of the watch and the iWatch and things that are being used? How useful is that to collect biological information from patients or subjects?
So you mean biomarkers like?
Like just things, heart rate, heart rate. And
we have done that. We are doing wireless weight, right, Chichi?
Blood pressure, pulse oximetry, peripherals, yes.
Anything
glucometers.
Any device that collects data of any kind that can be connected to the internet potentially has a way of collecting data. Can be de-identified, of course.
Is the issue of internet access pretty significant out in Western Nebraska in our region?
Not for mobile interventions. It's more difficult. I mean, I think it's been maybe 10 years ago when we worked with Dr. Buchanan on creating an intervention for smoking cessation. And also with P20, I think, Chichi, we built a we built an algorithm that allowed you to go to the hotel and then upload your data. If you went as a personal, you had a nurse practitioner or someone go to the subject, collect the data on an iPad application, and then bring it to the hotel to upload it. I mean, we can devise those. It's a lot more complex. But nowadays with dongles available for Wi-Fi access, you can essentially carry the Wi-Fi with you. So I don't foresee that as a problem today. I mean, it was 10 years ago for sure.
So, hello Deepak, it's Mark Riley.
Hey, Mark.
Howdy, nice talk. You briefly touched on the question of bias.
Yes.
And I'd love to hear a little bit more of your thoughts on bias. I mean, especially in light of there have been some high profile situations of like facial recognition that the data sets we've put into those have had deep biases that it's hard to notice that until we're vetting these algorithms. So.
Right, and that is why I especially with AI, I think it's extremely important that a partner who understands the machine learning algorithm from the inside rather than as a service is important. Because what happens is that when you use these services, you are essentially depending on them to provide a fair algorithm, and because they have trained the algorithm and so on. So when we do it, we basically take the algorithm and train it ourselves. So we know what data we are putting in, so we can explain to you, what is the reasoning behind this. So that's one way, obviously, to get around the issue of bias. But there are fundamental problems that are associated with two things in bias. One is bias in the algorithm itself. There is perceived fairness. So the fact is that a user or a consumer of the product or the person who's deploying the product may have a perception of unfairness. So there is that aspect too, which I have a PhD student studying that. It's a very new area, fairness. But algorithmic fairness is predominantly in the design of the algorithm, in the training data set that's used, and then how it is interpreted once the algorithm is used, given the training data set. So that's really, that's why it's so important to have expertise and not use it as a black box. So I guess is what I would argue. Yeah, but this is a very important area. And you said you were correct, even actually there is an article now published in the NIH database on a process for removing bias. In fact, I just read the article recently. I forget the author's name already, but basically it's a collection of authors who have now come up with a kind of a series of steps you can take to improve the chances that you will have limited bias. All algorithms will be biased. And just like all data we collect has problems. So this is the same problem. All design is biased in algorithmic design, but you can reduce the bias in many ways by being careful.
Yeah, great. Thank you.
Any other questions?
Well, no questions from anybody. Well, hearing none, thank you very much, Deepak, today for your great presentation and information, and your willingness to say contact me if anybody needs anything.
Yes, and I'm happy to send a slide deck just in case people want to see it.
Do that, and then Heather can post them with our on our website, on the IDS CTR website.
Perfect. Thank you.